probably wondering where I got this hat. Well, it all started a few months ago. Some friends of mine approached me and asked me to help them rob a bank. They knew I was studying computer science and thought I would be able to help them with a little problem. They were terrible drivers. And so they needed to know where in the UK they should rob a bank without getting caught if they then get into a car accident. Man, that Nerf gun is really, really strong. I just bought this to do this. This is like a tenner. Man, you can have someone's eye out with this thing. Good thing I took it to the bank robbery. I started by finding some data, and I stumbled upon this data set on Kaggle. And it's from official police records. And the police are famous for never making any mistakes, right? I started by plotting the longitude and latitude of all the points in the dataset on a graph, which went reasonably well. Something very interesting to point out is that where the points aren't denser than the members of the Exeter University rugby squad, you can actually make out the individual roads. In North Wales, for example, this triangle of accidents are actual roads in North Wales, made up of the A5, A427 and A494, meeting at Druid, Dolygyniw and Pontwypant. The reason it looks a different shape on Google Maps is because I used a different projection to the Earth. Google Maps uses the Mercator projection, whereas I use the plot it on a graph and hope for the best projection. But I checked the longitude and latitude manually and they were in the same place. All this is to say that, yes, we can actually accurately map this data to real UK roads. It's now time to bring up the first of our machine learning algorithms. The k-nearest neighbour algorithm is a classification algorithm, meaning that it aims to group data points into discrete classes that are determined beforehand by the programmer. In this example, we have two classes, blue and orange. It doesn't really matter what they represent, you just need to know they're two different classes. The algorithm does this by starting with a set of training data, or data where the class of each data point is already known. That's where all the dots are on this particular plot. Then, when we want to classify a new point, we find the k nearest neighbours of that point, see, it's all in the name, and then we classify the new point as the majority class of the points that it's closest to. The implementation of the k nearest neighbour algorithm I used produces kind of a patchwork of colours on the graph, where each coloured area represents what the majority vote will be in that area. An alternative classification algorithm is the SVM algorithm. SVM creates its classification criteria by calculating the line between the points of the classes, and then classifies future points based on which side of that line they are. I tried using SVM in this project, but SVM works best when only comparing two classes, so it didn't work for this problem. So, to apply KNN to the problem, I need to be able to classify all the data points in my dataset of car accidents. I did this by working out the proportion of accidents that received police response per police jurisdiction and classified every point in each jurisdiction as that ratio. Then I executed the algorithm and got this. Great, there's a massive plot in the way. I can't exactly just remove them because the algorithm, in its endless quest to be helpful, has also classified the oceans, so if I remove the points, it'll just be a big splodge of meaningless numbers. But this is okay, and I have a solution. I just need to go on a short tangent. Clustering is an unsupervised machine learning technique that aims to group data points into discrete classes. This means that the algorithm starts with a set of unlabeled data and through some process groups them into classes determined at runtime by the algorithm. dbScan is a clustering algorithm that measures these classes by the density of data points. When a data point is processed by dbScan, all points within a certain distance of it, the distance being tuned by the programmer, are added to its cluster. Then those newly added points will be processed and their nearby points will be added to the cluster. When there are no points in the cluster left to process, a new class is created and the next chosen point is added to a new class. This continues until no points are left unclustered. Clusters with fewer than a particular number of points are outliers. I wanted to group each separate island on the map into its own cluster so that I could draw an outline around each one of them, and this was the result. To get the outline of Great Britain and all the islands, I first had to remove several anomalies that formed their own giant box around most of the plot. I then applied the convex hull algorithm to the data. What the convex hull algorithm does is plot an outline around the data that encapsulates all the data points. Since Great Britain isn't a perfect polygon, I had to split it up into different sections. Before I did this, the map looked like one giant hexagon, and I ended up with this. All I need to do now is remove the plot from my previous result and add this instead, and I'll get a much cleaner result. And here is said result. There are several promising points around Liverpool, Manchester and Birmingham right here. However, they're all surrounded by higher risk areas, and since we'll have to do a getaway drive, across the country, we want somewhere where there is a clean run from A to B where we are unlikely to get any police showing up. Another quick tangent, the limitations of K-nearest neighbour are pretty evident. Unless I applied a generous helping of dbScan and some city markers, you would not be able to see anything on this graph, because KNN just tries to class points that make no sense, such as the middle of the ocean. Another slight limitation of my data is the fact that it comes from police records, which is a good thing because it means there's a sense of reliability about it, but also the fact that the data is then biased towards accidents that people felt the need to report to the police. So it's biased in favour of major accidents or accidents where criminal activity was already... Thirdly, dbScan also had issues. In return for not needing training data, Northern Scotland with its sparse data got divided up a bit randomly. I did try fixing this by using the k-means algorithm, since I could specify how many islands I wanted beforehand, i.e. how many clusters. But k-means just divided up Great Britain pretty much randomly instead of targeting each island. In the end, we went to rob a bank in Eastbourne, because along Terminus Road in Eastbourne sit about half a dozen banks all next to each other, meaning that we could rob them all quickly and then leave to drive back to Exeter while still being reasonably safe. And as you might be able to guess, the plan went flawlessly. Uh-oh. See you in France!